Okay, so here's the absolute minimal list of the things you're going to need to complete the project. First and foremost, you're going to need the three 3D printed components, and then you're going to need a 4 AAA battery pack, exactly like this one. The last time I went to Radio Shack to see if they had the same type of battery pack, because I wanted another one, they were just selling these, which this kind of battery pack won't work, so somehow you're gonna have to get your hands on one of these classic style battery packs. This is actually the more common style, so it shouldn't be too hard to track one of those down. Then you're going to need 24 LEDs. They can, of course, be any type of LED as long as they're 5mm and they have this flattened front. These are 45-degree emanations LEDs, but you can use any type of LED, any wavelength that you want. It's completely up to you. And then you're going to need a micro switch. I strongly suggest the kind of switch that is not a toggle switch but actually will lock in position, like the one that I used here. I got this little micro switch at Radio Shack, and that was like $4, I think. So that's really the preferable kind of switch. If you're really feeling adventurous, you could use a potentiometer, and then you could actually control the intensity of the light. Okay, and you're going to need some wire, some light gauge wire. Since this is low amperage circuit, I used a really light gauge wire just to go easy on myself, because the light gauge wire is a lot easier to feed through the channel in the middle. And you're going to need some heavier gauge wire for, well, two purposes actually. One for wiring the ring circuit here, and for another using as a primitive sort of tool to remount the channel in the middle, because with 3D printing there's a little bit of residue that will build up there, and that will need to be cleared if you're going to successfully wire the internals. And lastly, what you're going to need is, these are just standard tack nails that you can get at any drugstore or hardware store, used for hanging up like paintings and stuff. And this is what I use for the pins. These are made out of aluminum, which is really nice because it's a very easy to work metal, and they're very lightweight as well. And I ended up using, I think, the second to the heaviest gauge. They usually come with an assortment of nails, thicknesses, and anyway, just find the right thickness, and those will be used for the pins here that actually hold the joints together. As you can see, all you have to do is sand down or cut off the tip of the nail, and then it can just be pushed through there to make a nice solid and reliable hinge. So that's the overview of the materials that are needed. And of course you'll have to have a basic knowledge of how to complete a circuit, which most people have, and at least DIYers. And so yeah, that's the laundry list. So let's get started with the actual construction step by step. So when you first get the 3D printed parts from your 3D printer of choice, this is all they're going to be, is just 3 pieces of plastic, these 2 components of the clamshell, and then the main body. There will be no LEDs or switches or wires of any kind. And the first step, really, once you have the 3 components, is to prep the model. And normally this might not be necessary if 3D printing was slightly more advanced, but due to just the sort of natural limitations or foibles of the medium. There are some slight issues that have to be dealt with occasionally. And I'm going to zoom in here. As you can see, this is the point of entry for the wires here, and they lead into a channel that actually is completely enclosed by this projection here. And that channel runs from this little hole right here all the way back to the other side, where you can see the wires coming out right there, and it makes a quick stop right here in the middle where there's a cavity, where normally there's a cavity with a hole on each side, but I've put a switch and epoxy in here. So basically what you have to do is get some medium gauge wire of some kind, metal wire, or you could use nylon if you wanted to be really delicate about it. And you have to feed the wire into the channel and basically ream it out kind of delicately, because what happens is powder from the 3D printing process gets trapped in that channel and it can sort of clog it up. So you need to get the powder out of there so that you can easily feed your light gauge wire from one side to the other. And of course you're going to want to pull some wire out of the center channel where the switch is, so you can attach the switch later on. That's kind of important, so keep that in mind. But yeah, that's just sort of one of the unique characteristics of 3D printing that you have to compensate for, that powder filling in some of the channels. In fact, you'll need to clean the powder out of this groove too. I think I used a razor blade maybe for that, but yeah, this little groove here is very narrow. I'll zoom in so you can see that. And that groove was basically filled with powder as well, so that needed to be cleaned out. Once you're done doing the basic prep work, then you can start on the wiring the ring. And this is kind of a little bit tricky, but actually it's easier than cleaning out that channel. And so all you got to do is you take your standard 5mm LED, and if you'll notice on the ring, you can see how the legs, or the legs of the LED have been trimmed down really short, and I recommend cutting those off right below those little sort of crimped sections. In fact, I would say even like halfway between the crimp, and so like right about there, that's kind of the ideal length. And this is really important because those absolutely have to be as short as possible, because the back that protects the circuitry is the space is in here is pretty small, so it doesn't accommodate a lot of wiring. It's really the tolerances are very precise, so you have to make sure that those legs are nice and short. And I'll give a little profile here, you can see what I mean. But this is pretty much optimal. Maybe that's like a millimeter or so, maybe 1.5 millimeters all the way around. So obviously you want to have the polarity right on your LEDs so you don't accidentally wire one into the wrong position, because that would fuck up the whole circuit since it's in a parallel instead of in a series. And so all you have to do to keep that straight is pretty obvious. This is like the sort of 101 of LEDs. You'll notice there's a little flat inside on the the base of the LED. So you'll want to always keep that facing a consistent direction. And for my build here, I did it with the flat side of the LED facing outwards all the way around the ring, so that I would maintain a consistent polarity. And as for wiring the ring itself, it's actually pretty easy. I started at the base, and I had some wire, regular metal wire that was a smaller gauge than this wire, but this will serve as an effective demonstration. So all I did was I pulled a length of wire that I knew was going to be longer than the circumference, and then I soldered the end of the wire to the LED contact here, and then just bent the wire incrementally as I was stretching it out around the ring, and soldered each leg to the next segment of wire. So in other words, it's a continuous wire that goes all the way around. It was really easy. I was worried that wiring the LEDs was going to be very challenging, but in fact it only took me maybe 10 minutes to a side, so that was really easy. And then once I was done soldering all of those points, just pretty easy. I think anyone who can solder can probably manage that fairly easily. Then I soldered the wire that I'd run through here earlier to the two prongs of the sort of key LED right there. So effectively what happens is the electricity comes down here to these two wires, and then it goes through the entire ring, distributing the electricity equally to all the LEDs. If one burns out, the power will still effectively reach all the other LEDs, because that's sort of the beauty of parallel versus series wiring. So once that's finished, the ring, then you can attach the two protective clamshell sides. And there are two different depths here that you can see. One of these is thinner than the other. The thin one is the diffuser, and that goes on the front, and the thicker one is sort of the circuitry protector, and that goes on the back. And you'll probably want to clean these hinges in the same way that you did the internal channel here, by sort of reaming them out with a wire, and because there could be powder residue in there and buildup. And also I recommend, before you assemble the three components, that you make your pins using the tack nails, and you make sure that they're a good fit and length for the hinge system. So that way you will basically be all ready to go with that, and it won't be difficult to assemble. Now when it comes to actually attaching these, it's going to take a little bit of work, because the tolerances are very tight, and the way the hinges are designed, they're supposed to be high friction, high tension hinges, and that's actually a good thing. Good because it keeps them in place even when you're moving your camera around. So anyway, just this is sort of the most delicate part of the operation. You just want to be really gentle and careful when you're working these hinges together, so that you don't overly stress anything, because they could potentially snap. This plastic's really actually remarkably strong for what it is, but it's best not to take any chances, because obviously the 3D printed part is the most expensive, and you don't want to break these hinges because then it's basically junk. So yeah, just sort of gently, see these are already worked in, so I don't really have to be that gentle, but like I said, just be really gentle as you're working them in. And if you want to make it really easy on yourself, you can actually sort of push them together at this angle. In other words, a 45-degree angle, or in this case 180. And then thread your pins through that way. It'll actually be easier to line up the holes than if you were doing it at this angle. I discovered that while I was assembling this originally. And yeah, so it's not too hard, and I just did this as a stylistic thing. I put the pins on opposite sides. I don't think there's any actual like engineering necessity behind that, but I think it looks cool. Anyway, so that's how to deal with the assembly of the clamshell and the pins. And if you're lucky and you did your circuitry really well, your ring circuit, you won't have any trouble at all clapping these two sides together. But if it's even a little bit off, you're going to get a bit of a friction here because of the LED pins sticking out and blocking the back of the clamshell. So that's something to definitely keep in mind. You might have to do a little resoldering or whatever, bend the LED pins in order to get a nice clean fit. Keep in mind when you first put these together, this Lego style clasp here is going to be really stiff, and you're going to have to just gradually work that closed and open. Once again, being really careful not to put too much leverage on the hinges. It takes a while to get that worked in because, once again, the tolerances are so fine with 3D printing, and there's a little bit of residue on the plastic that just needs to be sort of flattened down and worn away. But once you get that clasped firmly together a few times and pulled apart again, it's going to work just fine, and it's going to stay together. It actually works even better than I ever could have intended it to work, so that's good. And okay, let's see. Lastly, pretty much is the completing the wiring, and that's just the most basic thing ever, which is soldering the battery pack to the other side of the two wires that are coming out the other end. And of course you want to have your polarity right, obviously, and your switch in between the power pack and the LED ring. And that's pretty self-explanatory. After you're done with the wiring, if you want, you can do what I did here, which I think is pretty much the optimal solution, which is just to take all the wiring, the excess wire. If you planned it right, they'll be really short, so you won't have to bundle up a lot in there. But the cavity here is actually pretty big. It's big enough to stash a little roll of wire, and so you want to take that excess wire, roll it up, and wrap it around the switch or whatever, and then fill this in with epoxy or some kind of setting glue that will give you a nice firm basis for your switch, so you can flip that easily and not have to worry about exposing your wiring or anything. And that's basically it. I mean, you're pretty much good to go once you've done all those things. And there's a couple of little like features here that I don't think I really need to point out, but I'm going to anyway, just to make this even more useful. And that would be this little hole in the bottom here is for the excess wire from the battery pack. You can just pull that down through the hole in the bottom and then push your battery pack all the way down. The way this is designed is that the battery pack slips in there, and then these flexible plastic parts here clip around the pack, holding it firmly in place. And luckily for you, since I updated the design to the exact specifications of the battery pack, that works a lot better than it used to. I had to file down the top of the battery pack, but that's been changed in the latest revision to the design that's been uploaded to Shapeways. And you can take this this extra wiring here if you want and stash it in the side of the battery pack, which I found is kind of useful. Just kind of keeps it out of the way. Yeah, so anyhow, that's the basic method for assembly and all of that, and I hope that this makes up for the fact that I didn't release a version of a video like this earlier, because I kind of just threw the design out there without any sort of assistance whatsoever, and it would be pretty hard, I think, for someone without any DIY experience to assemble this without really understanding some of the sort of intricacies of the design that of course no one but myself would know. So now hopefully anyone out there who wants to build their own can do it easily. So thanks for watching, thanks for being awesome, and good luck with your DIY projects.